QASS releases a completely new software with a simplified user interface. On the right, the three-dimensional image of the contactless measured magnetic component states. On the top left, the number of components to be tested and measuring positions are shown. Below this, positioning and measuring times. The whole process is started as a sequence, and the technician places the sensor on the defined position on the component, which is visualized in green. Is then prompted to pick up the next component, and when the time is up, the hardness is measured fully automatically, visualized in the graphics, stored in the lists, and saved in the database. At the end, we have a graphically displayed all measuring points. For the evaluation of the hardness, an almost linear relationship between magnetic measured value and surface hardness is used. The models are determined for the respective materials, stored in the system, and then used as a basis for measuring the individual components. Here we have an example of another component, a bearing ring. 8 positions are defined on the bearing ring, 2 rings are to be tested, and the sequence is started. This is done either by a skilled employee or a robot or a handling system. The measuring positions are controlled one after the other. The magnetic field is applied automatically, and the evaluation of the magnetic responses is carried out in QASS spectral analysis system. The results are plotted and displayed in an overview for each individual measuring point. In this case, the 2 components show 2 different hardness levels. The individual measurements are always visualized in the top right-hand corner. The overall results are saved in the database at the end, can be written out as a CSV file or saved as a PDF document. The table in the middle lists the part numbers and the measuring positions, possibly several runs to exclude measuring errors, and then measured micromagnetic energy responses and the correspondingly converted hardness values. The hardness can be specified in Rockwell or Vickers or Brinell. The new user interface is fully customizable, just like the measurement analysis from QASS. For some time now, we have introduced analysis modules that are scriptable. So is the interface and can be adapted in a very short time. It also has an editor that can be activated with the appropriate password. This allows us to arrange the individual modules on the surface freely and put them together according to the measurement needs. This means that the surface can be completely adapted to the measuring task, to the respective component. The surface can be saved if it is found to be good. There is a separate surface file that is linked to the measurement projects in our database, so that the matching surface is automatically displayed with the respective component. The arrangement of the control elements and also the measuring sequences can be completely adapted to achieve an optimal work and measuring sequence. The surface works hand in hand with the analysis tools behind it. This enables us to use the complex evaluation algorithms such as spectral analysis, air gap measurements, pattern recognition in the non-contact evaluation of component hardness and stress states, which we use for hardness measurement in a simple user interface.